Dr. Bosa science, Kwano Kabeti science, Rafu ya Bosa science, truth in a beta, truth in omega, truth in alpha science.
The Science Foundation College enamave ku Lwejjinja ng'oyingira kilomita emu. Somero lya Dene Boarding eri abawala n'abalenzi. Ku O-level tusomesa arts ne sciences ate A-level tusomesa sciences zokka. Omwana mulete ku The Science Foundation College. Ffe tusinga okusomesa sciences. Okumanya ebisingawo kuba ku 0753 8 27 09. The Science Foundation College, based on sciences and based for sciences.
Dr. Bosa is a teacher at the Science Foundation College, the best school that teaches sciences. At A-level, we teach sciences only. At O-level, we teach arts and sciences. Today, we are going to study molecular structure. Understanding molecular shapes is vital because action of enzymes and their inhibitors and activities of many drugs depend exclusively on their molecular structures. The atomic molecules like chlorine, hydrogen, oxygen are linear. The shapes adopted by atomic molecules depend on 1. The total number of electron pairs around the central atom, and 2. The number of bonding electrons and the lone pairs of electrons around the central atom. The valence electron pair, repulsion field, whisper, states that the repulsion between the lone pairs of electrons is stronger than the repulsion between the lone pair and the bond pairs of electrons, and is stronger than the repulsion between the bond pairs of electrons. So the repulsion between lone pair and lone pair is stronger than that one between lone pair and bond pair, is stronger than the repulsion between the bond pair and bond pair. Predicting the shapes of molecules. Case 1, total number of electron pairs around the central atom, there are 2. Number of bonding pairs are 2. Number of lone pairs, 0. The molecule will be of the form AX2. When we draw, it is AX, AX. The bond angle is 180 degrees. The name of this shape is linear. Examples of compounds with this shape and carbon dioxide. Case 2, total number of electron pairs around the central atom are 3. Number of bonding pairs are 3. Number of lone pairs is 0. The molecule will be AX3. The shape will be XAX. X, the bond angle will be 120. The name of the shape is trigonoplanar. Then compounds with these shapes are beryllium chloride, beryllium fluoride, sulfur trioxide, and carbon dioxide. So beryllium chloride will be like that. Chlorine, 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 and this angle here is 120. Sulfur trioxide will have a similar shape. Also, these are double bonds, not single bonds. Case 3A, total number of electron pairs are 4. Number of bonding electrons are 4. Number of lone pairs is 0. The molecule will be of the form AX4. The shape will be done like this, tetrahedral, and the name will be tetrahedral. Examples of compounds with the tetrahedral shape will be CH4, CF4, silicon tetrahydride, silicon tetrachlorides will have a tetrahedral shape. 3B, the total number of electron pairs are 4. The number of bonding electrons are 3. The number of lone pairs are 1. The molecule will be able to form AX free but with a lone pair of electrons. We do it like this. It is a pyramid, and then the shape is trigonal pyramid or triangular pyramid. Example of molecules with that shape is ammonia, phosphine. In ammonia, you draw nitrogen, you put a lone pair of electron, you put hydrogen and hydrogen and hydrogen. Similarly, in phosphine, you put a lone pair of electron, hydrogen, hydrogen, hydrogen. Phosphorus is at the peak of a pyramid, a triangular pyramid. Case 3C, the total number of electron pairs around the central atom are 4. The number of bonding electrons are 2. The number of lone pairs are 2. The molecule will be of the form AX2 with 2 lone pairs of electrons. Then it will be V-shaped. And examples is in water, oxygen has got 2 lone pairs. Then hydrogens form a V. Similarly, on sulfur, the electrons form 2 lone pairs. Then hydrogen form a V. Case 4. The total number of electron pairs around the central atoms are 5. The number of bonding electrons are 5. Number of lone pairs are 0. The molecule will be of the shape AX5. You do it like this. You imagine a triangle. Then one electron is at the top, one electron is at the bottom. The shape is triangular bipyramidal. And an example of compound with this shape is phosphorus pentachloride. In phosphorus pentachloride, you have a triangle, chlorine, chlorine, chlorine. Then you have one chlorine up, then one chlorine down, which is, you like imagine a triangle, then one is on the top of the triangle, one is in the bottom of the triangle. So it is triangular bipyramid. Case 5. The number of electron pairs around the central atoms are 6. Number of bonding electrons are 6. Number of lone pairs is 0. The molecule will have a shape like this. Imagine a square, and each of these chlorine are at the edge of the square. Then one projecting up, another one projecting down. The shape is octahedral. An example, silicon hexafluoride. In the silicon hexafluoride, the 4 fluorine atoms are at the corner of a regular square. One atom projects up, another atom projects down from silicon. Silicon is in the middle of a regular square. The 4 fluorine atoms are at the corner of the square. Then one fluorine atom projects upwards from the center, silicon, and another fluorine projects down from the center of silicon. Determining the number of lone pairs in an ion. For example, if you have got sulfate ion, you want to know the number of lone pairs on this sulfur atom, because sulfur is the central atom. Sulfur is in group 6. 1, 2, 3, 4, 5, 6 electrons. Sulfur has got 6 electrons on outermost shell. So one electron bonds with oxygen and goes with a charge. Another electron bonds with oxygen, goes with a charge. Then the 2 electrons will bond with 1 oxygen. Then the 2 electrons will bond with 1 oxygen. So in this molecule, there is no lone pair of electrons. So the molecule is going to be tetrahedral. The molecule is going to be tetrahedral. Another example is sulfite ion. Sulfur is in group 6, so it is 1, 2, 3, 4, 5, 6. One electron will bond with oxygen, which will carry a negative charge. Another electron will bond with oxygen, which will carry a negative charge. Then the third oxygen will bond with 2 electrons. Then there will be a lone pair of electrons. So in this molecule, there is a lone pair of electrons. So we shall draw it as, we shall put a lone pair of electrons. Then we shall put, so it is, this is tetrahedral, this one is triangular pyramid. Another example is called 7 iron. In called 7 iron, chlorine has got 7 electrons, 1, 2, 3, 4, 5, 6, 7 on outermost shell. One oxygen will bond with 1 electron and carry the negative charge. 2 oxygen will bond with 2 electrons. Another oxygen will bond with 2 electrons. Another oxygen will bond with 2 electrons. So in this molecule, there is no lone pair. So if we are to draw it, we shall put our oxygen. This is tetrahedral. That is tetrahedral. Shape is tetrahedral. Another example is ClO 3 minus. Again, chlorine has got 7 electrons in outermost shell, 3, 4, 5, 6, 7. One oxygen will bond with 1 electron and it will carry negative charge. The other 2 oxygen atoms without a charge will share 2 electrons from the outermost shell. This much will have a lone pair of electrons. So we shall do it as this. Put a lone pair of electrons. Then you put 1 oxygen with a charge. Then the other 2 oxygen without charge but with double bond, and this is triangular pyramid. Another example is ClO2 with a negative charge. Again, chlorine has got 7 electrons, 1, 2, 3, 4, 5, 6, 7. One oxygen atom will bond with 1 electron and it will carry negative charge. The second electron will bond with 2 electrons on outermost shell of chlorine, so there will be 2 lone pairs of electrons. So we shall draw this molecule with 2 lone pairs, and 1 oxygen carrying a negative charge, and this is V-shaped. That is V-shaped. With the carbonate, carbon is in group 4, so it has 4 electrons on the outermost shell. So 1 oxygen will bond with 1 electron and it has a negative charge. Another oxygen will bond with 1 electron and will have a negative charge. The third oxygen will bond with 2 electrons because it does not have a charge. So this carbon molecule will be drawn like this. And this one is the trigonal planar. Another example is the phosphate iron 2 minus. Phosphorus is in group 5, 1, 2, 3, 4, 5. And the phosphorus is in group 5, so it has 5 electrons in the outermost shell. 3 electrons will bond with 1 electron, and each one will carry a negative charge. Then the remaining 4 electrons will bond with 2 electrons. So this one has no lone pair of electrons, so the shape will be which is tetrahedral in shape. Then in nitrate, you can give so many examples. Nitrate is in group 5, so you have 1, 2, 3, 4, 5 electrons. One oxygen will bond with one electron and you have a negative charge. 2 of these electrons will not have negative charge, so will bond with 2 electrons each. So nitrate will have, which is trigonal planar. Then nitrate ion, nitrogen has got 5 electrons, 1, 2, 3, 4, 5. One oxygen will bond with 1 electron and have a negative charge. The second electron oxygen bond with 2 electrons from nitrogen. Then there will be a lone pair of electrons. So the shape here will be N with a lone pair of electron, and then this one, this will be V shaped. Then Cl4